Chapter 4, Working with List and Dictionary. CBSE Class 11, Informatics Practices. Subject Code 065. If you are watching this video or channel for the first time, please like this video and subscribe to our channel. Do not forget to press the bell icon for future content notifications. In this chapter, we explore two fundamental data structures used in Python to model and solve problems: lists and dictionaries. Content. Defining the list. List operations and traversal. List, key functions. List, key methods. Defining the dictionary. Dictionary access and traversal. Dictionary, key methods. Dictionary, key functions. 10+ Python code thoroughly explained. We will be sharing all code samples from this video and more through a Google Colab notebook. Let us get started. Defining the list. Definition. An ordered sequence that is mutable or changeable. Structure. Elements are enclosed in square brackets and separated by commas. Elements can hold mixed data types, integer, float, string, tuple, or even other lists or dictionaries. Please note that a list can contain duplicate elements. Access. Elements are accessed using index values, starting at 0. Negative indexing accesses elements from the right, starting at -1. Please see the dictionary image. We explore constructing different kinds of lists in Python. Homogeneous list where all elements are of same type, say integer. Same elements list. Contains only integers, 1, 2, 3, 4, 5. Heterogeneous list or mixed list where list members are of different types. Mixed elements list. This list mixes different types: the integer 10, the string hello, the float 3.14, the boolean true, and a nested list with the words nested and list. Let us see the output after executing this code. We can also create an empty list. It has no elements inside the square brackets. Another list is created with duplicates, called duplicate elements list. It contains integers that repeat, like 2 and 4. Let us see the output after executing this code. How to create a nested list. The variable is nested list. It holds lists inside a list, list 1, 2, list 3, 4, and list 5, 6. Finally, the complex list. The variable is complex list. It combines different data types: the integer 42, the string world, the float 2.71, the boolean false, and a nested list with integer members 7, 8, 9. These examples show how Python lists can store homogeneous data, mixed data, duplicates, and even nested structures. Let us see the output after executing this code. Lists allow for several operations to manipulate their contents. Concatenation. We can join two or more lists using the concatenation operator, the plus symbol. Note that concatenation requires both operands to be of the list type. Attempting to concatenate a list with a string results in a type error. The original lists remain unchanged unless an assignment operator is used to store the result. Repetition. The repetition operator, depicted by the asterisk, allows us to replicate the contents of a list a specified number of times. Membership. The in operator checks if an element is present in the list and returns true or false. Conversely, The not in operator returns true if the element is not present. Slicing. Slicing creates a new list by taking out a subset of elements from an existing list using the start index, end index, and an optional step size. Traversal. We can traverse a list, which means access each element, using a for loop. We will see examples of each of these operations and traversal in the next set of slides. The code you are seeing demonstrates two fundamental operations on lists in Python: concatenation and repetition. Concatenation, plus. This operation joins two or more lists together to create a new, single list. In the code, list 1 and list 2 are combined using the plus operator, resulting in concatenated list which contains all elements from both original lists in sequence. Repetition, asterisk. This operation creates a new list by repeating the elements of an existing list a specified number of times. Here, list 1 is multiplied by 2, creating repeated list where all elements of list 1 appear twice, in their original order. Let us see the output after executing this code. This code demonstrates the membership operators, in and not in Python. They are used to check if an element exists within a list or not. Let us see the last three print statements. Is banana in list 1? This checks if the string banana is present in list 1. Since banana is an element of list 1, this evaluates to true. Is grape not in list 1? This checks if the string grape is not present in list 1. Since grape is indeed not in list 1, this also evaluates to true. Is apple not in list 1? This checks if the string apple is not present in list 1. However, apple is in list 1, so this evaluates to false. Let us see the output after executing this code. Imagine list 1 as a box of fruits lined up in the order apple, banana, cherry, date, elderberry, and fig. List 1, 1:4. This means, start at position 1 and stop before position 4. Remember, Python starts counting at 0. So position 1 is banana, then cherry, then date. It prints, banana, cherry, date. List 1:3. This means, start from the very beginning, and stop before position 3. So we get apple, banana, cherry. List 1, 2:. This means, start at position 2 and go all the way to the end. So we get cherry, date, elderberry, fig. List 1:2. This means, take every second fruit. So we get apple, cherry, elderberry. So, slicing is just a way to pick out certain parts of a list, whether it's a few items, every other item, or even the whole list backwards. Let us see the output after executing this code. In this piece of code, we may use the list slicing for reversing and copying of the list elements. List 1::1. This is like flipping the list backwards. So instead of apple first, fig comes first, then elderberry, and so on. It prints the list in reverse order. List 1::. This is like making a copy of the whole list. It prints all the fruits again, just like the original. Let us see the output after executing this code. The same can be achieved by list methods reverse and copy. Iterating through a list is a common operation, and Python offers several flexible methods. Using a for loop, iterating directly over elements. This is the most Pythonic and common way to iterate through a list. The for item in list 1 syntax directly assigns each element of list 1 to the variable item in successive iterations. Let us see the output after executing this code. Using a for loop with index I and the range of length. It is actually iterating by index till the last element of the list. This method uses the range function along with len function to generate indices 0, 1, 2, up to length 1. You then access each element using its index, as shown for list 1, I. Let us see the output after executing this code. In this piece of code, we are using the enumerate function. Iterating with index and element. Element here means an entry or an item or a member in the list. The enumerate function is very useful when you need both the index and the element during iteration. It yields pairs of index, item, for each element in the list. Let us see the output after executing this code. Now, we are using a while loop, iterating by index. While less common for simple list traversal than a for loop, a while loop can also be used. We initialize an index variable, I equals 0, then continue the loop as long as I is less than the length of the list, incrementing I in each iteration to move to the next element. Let us see the output after executing this code. List key functions. Usage. Function name brackets list. Note: functions don't change the original list. Important functions that can be applied to a list are shown below. Len returns the number of elements. Sorted returns a new sorted list. Max returns the largest element. Minute returns the smallest element. Sum returns the sum of all elements. List converts to list. Any true if any element is true. All true if all elements are true. Please refer to the table for more details. We will be using it in many programs as part of the learning process in upcoming videos. List key methods. Usage. List.method name. Note: methods change the original list. Key list methods are: append, x, adds element x to the end. Insert, I, x, inserts x at position I. Remove, x, removes the first occurrence of x. Pop, I, removes and returns the element at index I. Sort, sorts a list in place. Reverse, reverses a list in place. Index, x, returns index of first element x. Count, x, counts occurrences of x. Extend, list, adds all elements from another list. Clear, removes all elements. Please refer to the table for more details. We will be using it in many programs as part of the learning process in upcoming videos. Defining the dictionary. Definition: a mapping data type. A collection of key-value pairs, or items. Structure: enclosed in curly braces. A colon separates key and value. Keys must be unique and of an immutable data type, number, string, or tuple. Keys serve as the index. Values can be repeated and of any data type. Mutability: dictionaries are mutable, items can be added or modified. Please see the attached image for a better understanding of key, value, and item. This code demonstrates 3 common ways to define or construct dictionaries in Python. Let's go through each one. 1. Using curly braces. This is the most common and direct way to create a dictionary. You define key-value pairs separated by colons, and each pair is separated by a comma, all enclosed in curly braces. Let us see the output after executing this code. 2. Using the dict constructor with keyword arguments. You can pass key-value pairs as keyword arguments directly to the dictionary constructor, like dict, name equals Bob, age equals 25. Note that the keys here are passed as variable names without quotes. 3. Creating an empty dictionary. An empty dictionary can be created simply by using empty curly braces, or by calling the dictionary constructor without any arguments. Fourth way of constructing a dictionary is using the dictionary constructor with an iterable of key-value pairs. The dictionary constructor can also take a list of tuples, where each tuple contains a key and its corresponding value. Let us see the output after executing this code. The fifth way of constructing a dictionary is from 2 lists using zip function. If you have 2 lists, one for keys and one for values, you can use the zip function to pair them up and then pass the result to the dict constructor. Let us see the output after executing this code. Accessing a dictionary item. This itself can be done in 2 ways. 1. Directly using a key in a square bracket. 2. Using the get method. This code demonstrates using keys to access elements within a Python dictionary. You can retrieve a value by placing its corresponding key inside square brackets after the dictionary. This is straightforward but will raise a key error if the key does not exist in the dictionary. Let us see the output after executing this code. This code demonstrates using the get method. The get method offers a safer way to access dictionary elements. If the key exists, it returns the corresponding value. If the key does not exist, it returns none by default, or you can provide a custom default value as a second argument. Look at line 8, where we use my_dict.get function with 2 arguments, country and not specified. If the key country is not available, it will return not specified. This prevents key error exceptions and makes your code more robust. Let us see the output after executing this code. Dictionary membership. We can check the existence of a key in a dictionary using the in and not in operators. Dictionary part retrieval can be done via methods like keys, values, and items. Together, these operators and methods give you flexible ways to explore and work with dictionary data in Python. Let us see sample programs making use of these helpers. This code demonstrates different ways to inspect and retrieve elements from a Python dictionary. Checking for key existence. The in operator lets you quickly verify if a specific key is present. It returns true if the key exists, and false otherwise. Getting all keys. The keys method returns a view object showing all the keys in the dictionary. If needed, you can convert this view into a list using list my_dict.keys. Let us see the output after executing this code. This code demonstrates getting all values of a list. The values method works in a similar way. It returns a view object of all the values in the dictionary. You can also convert this into a list using list my_dict.values. Let us see the output after executing this code. This code demonstrates getting all key or value pairs of a list. Key and value is collectively called an item. The items method returns a view object containing tuples. Each tuple represents a key and its corresponding value. This is especially useful when you want to iterate over both keys and values at the same time. Let us see the output after executing this code. Dictionary, key functions. Usage, function name within brackets, dictionary. Note, functions don't change the original dictionary. The useful functions on a dictionary are: length, returns the number of key value pairs. Dictionary, creates a new dictionary. Sorted, returns sorted keys. Maximum returns the largest key. Minute returns the smallest key. Any, true if any key is true. All, true if all keys are true. Dictionary, key methods. Usage, dictionary.method name. Note, a method changes the dictionary. The useful dictionary methods are: get, key, returns value for key, none if not found. It avoids key error. Keys, returns a view of all keys. Values, returns a view of all values. Items, returns a view of key value pairs. Update, adds updates multiple key value pairs. Pop, key, removes the key and returns its value. Pop item, removes and returns the last key value pair. Set default, returns value if exists, else sets default. Clear, removes all items. Del, deletes an item by key or the dictionary itself. Let's look at 3 common ways to iterate through a Python dictionary. First, iterating through keys. By default, when you loop directly over a dictionary, it goes through its keys. You can also call the .keys method explicitly. Inside the loop, you can access each value by using the key, like my_dict, key. Second, iterating through values. The .values method returns all the values stored in the dictionary. This is useful when you only care about the values, not the keys. Third, iterating through key or value pairs. The .items method gives you tuples containing both the key and its value. This is often the most convenient approach when you need both pieces of information, as in for key, value in my_dict.items. These 3 techniques cover the most common ways to traverse a dictionary in Python. Let us see the output after executing this code. This code gives us a simple demonstration of basic CRUD operations on a Python dictionary. CRUD stands for create, read, update, and delete. Initialization. We begin by defining a dictionary called records. The keys, numbers like 1, 2, 3, 4, and 5 act as unique IDs. Each ID maps to another dictionary holding fields such as name and age. Create. To add a new record, we use the .setDefault method. For example, records.setDefault, 6, name, Frank, age, 29. This adds the entry only if the key 6 does not already exist. If it does exist, the method simply returns the current value without making changes. Update. To modify an existing record, we use .update. For instance, records, 1, .update, age, 31, city, New York. This changes Alice's age from 30 to 31, and adds a new field called city with the value New York. Delete. To remove a record, we use .pop. The line records.pop, 2, deletes the record with ID 2. The method also returns the removed value, though in this example, it isn't captured. If you try to pop a key that doesn't exist, Python raises a key error unless you provide a default value as a second argument. This minimal example sets the stage for the next set of activities and lessons. Please access the Google Colab notebook and play around with this code. Thank you for watching this video. Please see the description for links to Google Colab Notebook and other resources. Stay tuned for the next Python course and MCQs.